Business analytics is a broad field that combines statistics, computer science, and information systems. It's used in many areas, including marketing, finance, and human resources. Unlike data science, which focuses on developing applications, business analytics is centered on analyzing data to extract value and insights. To get value from data, you need to understand the business context, ask the right questions, and use appropriate analysis models. The numerical results aren't useful without clear, actionable business insights. There are three main types of business analytics: descriptive, predictive, and prescriptive. Descriptive analytics summarizes what has already happened. This is also known as business intelligence, BI. Examples include financial reports, public health statistics, and crime rates. Descriptive information can be presented in written reports, tables, graphs, and maps. BI uses past data from multiple sources to help with decision-making and identify problems. For example, a BI question might be, how many country songs were skipped by a US-based female listener in the first quarter of 2020? Predictive analytics uses historical data to forecast what could happen in the future. It helps identify associations between variables to estimate the likelihood of a specific outcome. Examples include predicting which customers are likely to respond to a marketing campaign or which credit card transactions are likely to be fraudulent. Predictive analytics is considered an advanced prediction method and relies on statistics and data mining techniques. Prescriptive analytics uses optimization and simulation to advise on what should be done. It explores various possible actions and suggests a course of action. Examples include providing advice on scheduling employees to meet customer demand or choosing an investment portfolio to meet a financial goal. Prescriptive techniques are considered highly valuable because they offer actionable recommendations. The Cross-Industry Standard Process for Data Mining, or CRISP-DM, is an iterative 6-phase model for analytics projects. Phase 1. Business Understanding. You start by defining the business problem you want to solve. Without clear questions, data mining efforts are unlikely to be fruitful. Phase 2. Data Understanding. This is a crucial preparatory step. It involves understanding where the data came from, who collected it, and what the variables mean. It's essential to verify the data's accuracy and reliability, as inaccurate data can lead to wrong decisions. Phase 3. Data Preparation. In this phase, you get the data ready for analysis. This can include combining data sets, removing anomalies, and reformatting data for consistency. Phase 4. Modeling. A model is a computerized representation of real-world observations. It's where you apply algorithms to find patterns in your data. Models are used for both classifying and predicting. Phase 5. Evaluation. You evaluate how valuable your model is. This involves both mathematical techniques and human expertise. Phase 6. Deployment. If the model is useful, you deploy it. This can involve automating the model and integrating it with existing systems. Data comes in many forms. Structured data is in a predefined row-column format, like what you'd find in a spreadsheet or database. Examples include financial data and point-of-sale transactions. Today, experts agree that structured data accounts for only about 20% of all data used in business decisions. Unstructured data does not conform to a predefined format and is often textual or multimedia. This includes written reports, emails, photographs, and social media data. The remaining 80% of data used in business is unstructured. Data can also be categorized as cross-sectional, which is collected at a single point in time, or time series, which is collected over several time periods. A variable is a characteristic of interest that differs among observations. Variables are either categorical or numerical. Categorical variables represent categories and arithmetic operations on them are not meaningful. Examples include marital status, Numerical variables represent meaningful numbers, and arithmetic operations are meaningful. They can be either discrete, like the number of children in a family, or continuous, like investment returns. There are 4 scales of measurement for variables: nominal, ordinal, interval, and ratio. Nominal scales assign numbers as labels without any additional meaning. Ordinal scales build on nominal scales by assigning numbers that reflect a rank order. Interval scales have meaningful differences between numbers but not meaningful ratios because they lack an absolute 0 point. An example is temperature in Celsius or Fahrenheit. Ratio scales have all the attributes of interval scales but also include an absolute 0 point. Examples include height and distance traveled.